Hello and welcome to another video. My name is Jonathan Tipo and today I'll be going over properties and changes. So properties and changes are actually split into two different categories, right? There's physical properties and there's chemical. So physical properties, a great way to remember it is you can use one of your five senses to see it, right? So is it shiny? Is it shiny? Is it smooth? Is it bumpy? This and this and this, right? It also deals with the states of matter. Right, so quick refresher, what are the states of matter? Got solids, liquids, and gas. And what separates these three are energy. So physical properties also can deal with energy, right? Chemical properties is stuff you think of when I say chemistry. So when I say chemistry, you might think of atoms, you might think of elements, you might think of bonds, you might think of all those things. And what we're talking about is things at the molecular level. All right, so things at the molecular level deal with chemical properties. So let's talk about changes. So let's do this in green. So the most common changes you'll see is changes in size. So if I rip it up, if I break it down, if I take a glass bottle, I shatter it, or changes in energy. Right, and so that deals with this one. So like melting, boiling, that type of stuff. Right? So also, the way you remember physical changes is if the thing is the same before and after. The thing we're talking about is the same before and after. Right? And let's talk about chemical changes. So if physical changes the thing, so the thing is the same, that means chemical changes, the thing changes before and after the change. Right, and I'll get to that in a moment. It'll be clear when I do examples. So let's talk about this. You got ice, water, and some steam/vapor, whatever you want to call it. Are these physical or chemical properties? Well, they're physical. Even though there's different states of matter, essentially, they're all the same thing. And that's what I mean, right? Because at its core, it's all H2O. So how do you go from ice to water? Well, you heat it up, or you add energy in the form of heat. Same thing with water to gas, right? Plus energy in the form of heat, right? And because these are just changing, and these are the same thing, essentially, changing between different forms, by adding heat or taking away heat, these are physical properties and physical changes. Right, and so what if I say, here's another example, piece of paper, and I rip it up like 8 times, right? So you got 8 small pieces of paper. Well, this is a physical change, right? Physical. Why? Because even though you rip it up 100 times, at its core, it's still going to be paper, right? You have the same amount of stuff, you have the same thing before and after the change. But let's say this is a log, right? Going camping, we find a log and we set it on fire, right? So what do you see? You see smoke coming out. You may see a pile of ash at the bottom, right? And so at the end, we're going to be left with ash. You might see a little bit of log, but a lot of it is just going to go into smoke. Right? And so this is what I mean by the thing changes. Because you no longer have a log, right? You started off with a log, but now you have a whole bunch of H2O that's released, You have a whole bunch of CO2, or carbon monoxide, carbon dioxide. They're all over the air, right? And so you no longer have the same things that you started with. And so that's why burning and cooking and all these things, they're chemical changes, right? And so I hope you understand what these physical and chemical changes are, because we're going to move on. Right, so we got two other properties, right? Intensive and extensive properties. So intensive and extensive properties, they're properties that rely on different things, right? Or in terms of intensive properties, they do not rely on amounts of stuff. So I don't know how other peer leaders might teach this, but here's how I teach it, right? You can find it within every single thing, right? So say you have a rock. Let's do an example. Say you have a rock, right? Intensive properties do not rely on the amount of rocks that you can have. So say we actually have two, right? And we line them up side by side. So intensive properties are going to be stuff like the density, right? So the density of the rock's never going to change. You're going to have 50 rocks and the density of those rocks won't change. You can have 50 rocks and the temperature won't change. You can have 50 rocks and the boiling/melting point of those rocks aren't going to change because they're found within the actual thing, right? But extensive, it's external, right? So the more you add, the more it'll change, right? So say instead of 2 rocks, we have 50 rocks, right? So what things do you think, or like what properties that you can name off the top of the head that you might think is extensive, right? So if I had 50 rocks, what will change? Well, you might think, oh, I can't carry 50 rocks because the weight/mass would change, right? Because, you can carry 2 rocks, you can't carry 50, right? Or what about where am I going to change? Where are I going to keep it, right? So the length would change, right? So the more rocks you had, the bigger your rock would be, right? So if you line all the rocks side by side, you would have a longer line if you had more rocks. Weight, mass, length, volume, right? That stuff would change, right? Because it's based on external things, right? The more you add, the more you come from the external, the more these things or these properties change. And so we're going on to our last thing, which I want to talk about is mixtures, right? So mixtures are pretty simple, right? Mixtures are 2 or more things. That's literally it, right? 2 or more things, and these things could be elements, molecules, compounds, whatever you want. It's got to be 2 or more. So homogeneous mixtures are consistent and the same throughout, right? So let's talk about Kool-Aid, right? So we make a box, we make this super big jar of Kool-Aid, right? And we take small cups out of it, right? So here are small cups of Kool-Aid. Every single one of these cups are going to be exactly the same. That means it's a homogeneous mixture, right? Homo, same. Homo, same. We are Homo sapiens. We are the same species, right? Heterogeneous mixtures, or hetero, are different, right? So I'm talking about salads, right? So we go to this place and they give us a big salad, right? And there's tomatoes, there's croutons, there's, ranch dressing. That's not ranch, but that's dressing, right? So every bowl of salad is going to be different, right? Because this might have 1 tomato and 2 croutons, versus this one only has 1 crouton and 2 tomatoes. So every sample of this, and we're talking about samples here, right? Every sample is going to be different. So that really deals with everything Module 1 talks about, properties and changes. If you have any more questions, just refer back to this video as always, or even just ask your peer leader if you need any more help. They'll be happy to help you. So that's about it. That's all my video has to say on properties and changes. We'll see you in the next one.